Welcome solution to All India ACAS test series Medical 2019 test number 1 code C for physics and test date 15/10/2017. So we are going to start from question number 1. The velocity of particle moving in a straight line varies with time 3 plus 2t meter per second. The displacement covered in first 3 seconds is. So I need displacement, and this question is based on application of integration. So as you know, the velocity is given by dx over dt. Okay, and this is the differentiation of position with respect to the time. But in this question, we need dx, v into dt. And you know, according to the problem, the velocity varies 3 plus 2t into dt and dx. Now, I need limits. So first I am going to use the limit. If I write t is equal to 0, t is equal to 0 means initial position. So I need at time t equal to 0, the position of the particle, I mean to say initial position. So if I write x initial at time t is equal to 3 seconds as per the question 3. So if I write x final. If I use the concept of integration, so we have final position minus initial position after integration, and the integration of this part 3 plus 2t, so 3 dt, and limit is 0 up to 3. The second part 2 as a constant, t dt 0 up to 3, right? So final position minus initial position, and that will give you 3t 0 up to 3 plus 2t square upon 2 limits 0 up to 3. So if I use upper limit minus lower limit, similarly 2 will cancel out, so you will have 9 minus 0. So that will give you 9 plus 9, I mean to say 18 meter. But question demands the displacement. मुझे चाहिए displacement, and by the definition you know that the change in position, final position minus initial position gives us displacement. So we can write here displacement is 18 meters. So my option number 3 will be correct. Okay. Now let's move on question number 2. If the rate of change in velocity with respect to time is constant. So what is the meaning of this line? If rate of change in velocity with respect to time is constant, it means acceleration is constant. So my first observation is acceleration is constant. And next, after 6th second will be same as that after 11th second. Then the particle returns to the starting point after. Because acceleration is constant and body returns to the initial position. So this is possible only and only if the direction of initial velocity and acceleration both are in opposite. So we can compare this question with the motion under gravity. So if I imagine this is the point of projection, okay? So direction of initial velocity in upward. So you know the acceleration due to gravity will act in downward, because question says acceleration is constant, and here you know the acceleration due to gravity is also constant. So now if I divide the journey of the ball in a regular time interval like that, suppose if I compare like that, according to the problem, if I take this is 6th second, and in this situation the body is going up with velocity v, and according to the problem after 11th second body will be in same position. ये तभी पॉसिबल होगा जब ये 11 सेकेंड में यहां पे रिटर्न करेगी। अब अगर मैं यहां पे देखूं, क्योंकि क्वेश्चन में बोला जा रहा है कि बॉडी अपनी इनिशियल पोजीशन पर आएगी, तो नेक्स्ट ये 6 सेकेंड है, और you know the time taken by the ball to upward journey will be equal to the time taken by the ball to downward journey। जितना टाइम ऊपर जाने में लगता है उतना ही टाइम वापस आने में लगता है। तो 11 सेकेंड ये है, तो यहां पर आप देख रहे हैं कि ये 6 सेकेंड है। 6 और 11 दोनों पर पोजीशन सेम है, तो मैं बोल सकता हूं कि दिस इज 17 सेकेंड। So what will be the total time? So we can conclude that total time will be 6 plus 11, and that will give you 17 second. Okay. Now we are going to take question number 3. A particle moves in a straight line with velocity t minus 2 whole of square meter per second, where t is time. Then the velocity of particle where acceleration is 0. So look at the important point. The velocity of the particle where acceleration is 0. तो सबसे पहले हम लोग क्या करेंगे, हम ये चेक करेंगे कि किस टाइम पर acceleration 0 है. So now, according to the problem, velocity is t minus 2 whole of square, right? So if I go for acceleration, acceleration is given by dv over dt. So if I place the value of velocity, so v is given by t minus 2 whole of square, right? But according to the problem, I need time where or when acceleration is 0. So if I put acceleration is 0, if I differentiate this t minus 2 of whole square, 2t minus 2, 2 minus 1. This is the differentiation of this power. So if I go for the differentiation of this part, t minus 2 will get 1 minus 0, because differentiation of 2 is 0 because it is a numeric constant. So we have 2t minus 2 only, और ये 0 के इक्वल होगा. So on solving you will get time t is equal to 2 seconds. So this is इस टाइम पर, because question says where t is time, then velocity of particle where acceleration is 0, or at t equal 2 seconds velocity will be 0. When I place acceleration is 0, then we'll get time t equal 2 seconds. So this is the time when acceleration is 0, but on that time I need velocity. So velocity is t minus 2 whole of square. So if I place the value of 2 seconds, 2 minus 2, so that will give you 0. So this is your final answer. The velocity will be 0 where acceleration is 0. So my option number 2 will be correct. So we'll start question number 4. If velocity and acceleration are given by the options, when velocity v is 0, a acceleration must be non-zero. When velocity 0, acceleration may be 0. But you have to be very careful. इन conditions को देखते हुए हमें ये बताना है कि ऑप्शन A और D, B और C, A और C, B और D इनमें से कौन करेक्ट होगा. बट सबसे पहले हमें ये जानना है कि क्या वेलोसिटी 0 होने पर एक्सेलरेशन 0 हो सकता है, या एक्सेलरेशन 0 होने पर वेलोसिटी 0 हो सकती है. सो नाउ we will discuss only two conditions. When acceleration is 0, when acceleration is 0. First I am going to discuss this condition. When acceleration a is 0, then we know velocity may or may not be 0. You know, if velocity is constant, then you can say velocity is there, but velocity is constant, so there is no acceleration. So this is possible. And if I go my condition number 2, when velocity is 0, तो क्या मैं कह सकता हूं कि acceleration 0 होगा? So when velocity is 0, then acceleration may or may not be 0. Yes, in the case of motion under gravity, if I project a ball, then at topmost point, velocity will be 0, but acceleration due to gravity is non-zero. So finally, when acceleration is 0, then velocity may or may not be 0. And second condition is when velocity is 0, then acceleration may or may not be 0. So on the basis of that, my option number 2 will be correct, because option number 2 में लिखा है B and C, और B पे बताया जा रहा है कि when velocity 0 है, acceleration may be 0. It is correct, yes. And of C, when acceleration 0, velocity may be 0. So my right choice is option number 2. Let's move on. Question number 5. A bus moving with constant speed on a straight road takes a turn at a curve with the same speed. The correct option is. So first I am going to make the track. Here we'll see, if I draw a tangent, velocity v1, then velocity v2, velocity v3. And you know that velocity has two things. One of them is direction and another is magnitude. If direction is constant, then velocity is not constant, because velocity depends on two things. अगर इसका magnitude और direction दोनों constant होंगे, तब आप कह सकते हो कि velocity is constant. But in this question, the straight road takes a turn. जब ये turn लेगा, तो direction of velocity will change. If direction of velocity is changed, so we can say velocity is change. Now I am going to take our options. First option says its velocity is not changed. No, because the direction of velocity is changing. First option nahi ho sakta. If I go option number 2, acceleration during turn is 0. No, because if velocity is changing, then acceleration during turn is not 0. So second option is not correct. First option is not correct. And if I go option number 3, acceleration during turn must be constant. No, because velocity is going to change. So third option is not correct. And fourth option says its velocity is changed. Yes. So my final answer is option number